Hello everyone. Today we are going to see about the component called transistor. Already we have learnt about diode. After that it was invented, we have invented this transistor. After the invention of transistor, there was a boom in the electronics field. What is this transistor? We are using this transistor everywhere in this electronic world. All this mobile is made up of electronics, transistor, TV, fridge, everything we have a transistor inside. Okay, before knowing about this transistor, first we need to know why we need to know about a transistor. For that we need to know what is the application of this transistor. When you see a transistor anywhere, the first thing comes in your mind is amplifier. So we have to think about amplification. So what is this amplification? Amplification means, let us take this PA circuit, that is public addressing circuit. What is this? There is a mic, in between there is an amplifier, and there is a loudspeaker. We will see this always in our political propaganda when they are using. This is called public addressing system. What happens here, when someone speaks in this mic, that sound signal is converted into an electrical signal. Then after that the electrical signal again converted into a sound signal by means of a loudspeaker. Okay, then what is this amplifier? What this amplifier is doing here, normally electrical signal is represented in the form of waves, that is electron movement, we will take it in the form of wave. That's why I have drawn it here in this way. What is this amplifier will do? This amplifier will convert the low voltage of this signal to high voltage signal. So low level input signal is converted into high voltage level output signal. This is the operation of this amplifier. This is called amplification. Using this amplification concept only, we are making a dynamic output sound from the loudspeaker. Okay, I hope you understand this. So this is the main operation of this transistor. Okay, what are else the operation of this application of the transistor? You can also use this as a switch. Okay, as like your diode, you can use this like a switch. You can also use this like a oscillator. What is this oscillator? Oscillator means it will generate a frequency. It will on its own it will generate a frequency. You know 98.3, 103.5, lots of frequencies have been transferred in your FM. You are hearing some song. That frequencies if you want to generate, then you have to use this oscillator. So not only this, there are lots and lakhs of application there for a transistor we can see. Okay, now with this idea we are having an urge to know about what is a transistor, how it is created. Okay, normally a transistor we can take two diodes back to back, we are connecting. This is PN and this is again NP. We are connecting it back to back. It will converted into like this NPN structure. So this is how a transistor structure can be understood. But normally a transistor is not created by means of two diodes. For a consequence of growth, I am saying this in this fashion, not for a real time. Normally what we did, semiconductor, we have taken the sand, then that is converted into a semiconductor silicon, then it is converted into p-type, n-type material, again now to diode. From that diode now we have converted to a transistor. Now this transistor is a three-terminal device. Three-terminal emitter, base and collector. Diode is a two-terminal, isn't it? What are the terminals? Anode and cathode. So leave that. Here now it is three-terminal device, emitter, base and collector. Okay. Now what is a transistor? Transistor is named because of transfer resistance. Transfer resistance. So transfer resistance is converted into transistor. Okay sir, you said amplification is the main application of this transistor. How amplification is created by means of this component called a transistor? How it is created? By means of this transfer resistance only. What is this transfer resistance? We should know how the amplification is created. First you should know about the doping level of this emitter, base and collector. Generally, normally your emitter is heavily doped, that is more impurity is added. Base region is lightly doped. Again collector region is moderately doped. Okay, due to this what will happen? We know already, if someone is heavily doped, what happens to the junction of this we will take this as a diode. Okay, what happens to this junction? If I am giving more heavily doping, then this junction becomes, this wall becomes very thinner, that is junction become very thin way. Okay, then the other side collector is moderately doped. If you moderately dope this side, what happens to this junction? This junction will be somewhat bigger. Okay, the wall is very thin means it has less resistance, wall is big means it has high resistance. Okay, that's how you are transferring a current from low resistance to high resistance. As we know, emitter, the name itself says that it emits the current. Collector, the name itself says that it will collect the current. Okay, so the current moves from emitter to the collector. At that time, the current moves from low resistance region to high resistance region. Here this wall is having low resistance, this wall is having high resistance. Due to this, what is happening? We know from Ohm's law, V equal to I into R. Okay, so voltage is depend upon the resistance. If resistance is less, voltage will be also less. If resistance is more, voltage will be also more. So now directly you can see this side the resistance value is less and this side the resistance value is more. Automatically the voltage from the input side will be less. The output side voltage will automatically become more since the resistance is increased. So resistance increases, voltage also increases. So this is how amplification takes place in a transistor. Okay, then we will think about what are the different types of transistors available. There are different types of transistors. There is bipolar junction transistor which is called BJT, then field effect transistor which is called FET. In FET there are different types. One is junction field effect transistor, another one is metal oxide semiconductor field effect transistor. So there are different kinds of transistor we are going to see in different classes. Okay, next we should know about the bipolar junction transistor first. What is this bipolar junction transistor? This bipolar, what is this bipolar? Bipolar means why it is named as bipolar? It is going to be work with both the majority charge carrier and minority charge carrier. Its operation depends upon both the majority charge carrier and minority charge carrier. What is that? Both electrons and holes contributes the operation for this bipolar junction transistor. Okay, what are the types of BJT? What are the types available? NPN and PNP transistor. Okay, how NPN is created? NPN means we will take a p-type semiconductor and it is sandwiched in between two n-type layers. That is how we will create a NPN transistor. Okay, how PNP transistor is created? We will take a n-type semiconductor and we will sandwich that between two p-type semiconductors. This is how we will create a PNP transistor. Okay, we know what are the terminals: emitter, base and collector. So the region between two things is called base. Okay, one side is emitter, another side is collector. Okay, then this is the structure of your transistor. What is a circuit symbol? This is the circuit symbol of your transistor. This is how you have to draw the transistor in circuits. Okay, so here also the region which is common to both terminals is called base, and this side is emitter and this side is collector. And here also the same, NPN, PNP. Sir, both are looking similar. What is the difference between these two? The arrow mark what you are going to put will differentiate whether it is an NPN transistor or a PNP transistor. Okay, for a NPN transistor, in the emitter side you have to put a arrow mark which points outwards. So if the arrow mark points outwards, then this type of transistor is called a NPN transistor. Okay, what is a PNP transistor? In this you have to mark the arrow mark in the inwards direction. Okay, this is a PNP transistor. Okay, then next topic is transistor biasing. What is this transistor biasing? Already we learnt about diode biasing. Biasing means what? We have to put a battery, then only this transistor will operate properly, isn't it? We have to apply a appropriate voltage to the proper terminals of this transistor. What are the terminals? Emitter, base, collector. We have to put the battery in this terminals. Okay, normally whenever you see a transistor, you should know whether if the transistor is working properly, then conformly what is the biasing given to it is emitter base is given forward bias, collector based junction is given reverse bias, then only the transistor will work properly. Okay, if you give different biasing to the terminals, then it will not work properly. You take a mic in your remote control, you reverse the battery side. If the mic, will your mic works properly, will your remote works properly? No. So there must be a proper side in which you have to put the battery. In that way we have to see this. So when you want to, if you want to make this transistor work properly, then you have to use a emitter based junction, you have to apply forward bias, and collector based junction you have to apply reverse bias. Okay, so this is now a transistor symbol. So a NPN transistor. So this is emitter and this is base and this is collector. Emitter, base and collector. So from this understanding, let us give a proper biasing to this transistor. What is that? Emitter base forward bias. This is emitter base. Forward bias means what? N is connected with N and P should be connected with P. Okay. Then collector base reverse bias. How to connect this? This is collector base junction. Collector base junction. Okay. Collector base reverse bias. Reverse bias means what? N is connected with positive and this P is connected with negative. This is how you have to connect, give biasing to this transistor. Okay. In the same way here also, P is connected with positive and negative for forward bias. P is connected to negative, N is connected to positive for reverse bias, isn't it? If you give for both the side forward bias, then it will take the transistor to the saturation region. Okay, otherwise if you give both the sides reverse bias, then it will take the transistor to the cutoff region. So these regions, if you bring the transistor, then transistor will not work. So you have to give a proper biasing to the transistor, then only it will work. So hereafter, whenever you see a transistor and if the transistor is working properly, then surely what biasing is given? Emitter base they have given forward bias and collector base they have given reverse bias, isn't it? There are two diodes. We know each diode should be given forward bias or reverse bias. That's what we are planning, which bias to be given to each and every diode. Okay, so in this we have learnt about completely about what is the transistor, what are the types of transistor, what is the application of transistor, why we should know about a transistor, then how amplification takes place in a transistor. Next thing, in the bipolar junction transistor, what are the different types of bipolar junction transistor. After that we learnt about different biasing, how we have to give the proper biasing for the transistor for the proper operation of the transistor. I hope you love this video. If you love this video, kindly like our video, share and subscribe to our channel. Thank you. If we get more views, we can do more videos. So kindly subscribe our channel and share with your friends. Thank you.